Welcome, I'm Dr. Lou. Let us examine the reaction we are going to observe in today's demo. In this reaction, I'm going to take solid magnesium and react it with the oxygen gas that is found naturally in air to form magnesium oxide. The magnesium oxide we are going to form will also be a solid. If we look carefully at the reaction, you will notice that there is a Greek letter delta above the arrow. Such a delta represents heat or energy. In order for this reaction to occur, we will have to add a substantial amount of energy in the form of heat, which we will obtain using a Bunsen burner. Now, most reactions are exothermic, meaning the products have more energy than the reactants, and I will now discuss a little bit about how we can determine that this reaction is exothermic. Here we have a reaction diagram for a typical exothermic reaction. The two main things to focus at on this diagram is your delta H and your delta E sub A. The delta H is going to determine if the reaction is endothermic, meaning the products have more energy than the reactants, or if the reaction is exothermic, meaning the products have less energy than the reactants. In this particular case, we can see that we have an exothermic reaction. The y-axis of this diagram is energy. As you go down towards the bottom of the plot, there is less energy, so the products have less energy than the reactants, which makes the value for delta H be a negative. Okay, I also talked in the previous slide about the reaction requiring energy to proceed. If you look at this diagram, you will see there is a large positive value for delta E sub A. Delta E sub A is the activation energy. So if you have a strip of magnesium metal and leave it in the room for maybe 10 or 15 minutes without adding heat from a Bunsen burner, nothing is going to happen because the magnesium did not absorb enough energy to go over this big so-called speed bump. So in order to get the magnesium to turn into the oxide, not only do we need oxygen, but we also need a substantial amount of energy, which is in the form of heat from the Bunsen burner. When we carry out the reaction, which we will see in a moment, you will notice a bright white light forming. Remember that light is a form of energy. If light is released during a chemical reaction, that means the molecules that are reacting are releasing energy, and we have an exothermic reaction. I am going to take a small piece of magnesium ribbon and using crucible tongs, hold it in the flame of the Bunsen burner. Notice the bright white light being emitted. This bright white light is an indication that this reaction is exothermic, meaning that a lot of energy is being given off. When we go and try to pick up some of the magnesium that is dropped onto the lab bench, we will see that it is nearly impossible. The reason being is that the magnesium oxide has very different properties from the original strip of magnesium metal. The magnesium oxide is a white powder that is ash-like, and it is nearly impossible to pick up with the crucible tongs. This change in properties is a very good indication that we have actually had a chemical reaction take place. Also note that there is no way to easily convert the magnesium oxide, which is in the form of a white powder, back into the solid strips of magnesium metal which we started with.